Merhaba arkadaşlar. So we will continue with chapter 6 to our discussion on object-oriented design, and the key parts of chapter 6 will cover how we can go by the software development activities, what are the steps in designing a software, an overall package as a whole, and this is going to be also important for your project designs because you will at the end deliver a software package, a program which is going to be useful for some certain task. And in doing that, how can we determine the classes and objects that are needed to implement our application? So for your projects, what are the different components of the overall design should be, and how you need to interact these objects and classes with one another is a key part of this design process, and that's what also we will be covering within this chapter. And then the relationship among the classes is also important. So it's always good to utilize or use the objects or classes that you have created before. So in order to come up with a good design, what you should try to do is that divide your overall task or program into smaller pieces such that you can use one piece in the rest of the application. So you do not rewrite the same code over and over for different pieces. And the overall goal here is that, again, to come up with a good design which has certain relationships between classes. So these relationships are also important, and we would like to utilize that as much as possible in the class as well. And then the static modifier you already know, but we will extend the knowledge that you have there. How to write interfaces. I mentioned interfaces in the previous lectures, if you recall. These were mainly related to the button clicks, if you remember. So we had this interface that we implemented for action listener, right? So we had the action listener which we were listening to, and those were the interfaces, and we will again see how this is actually implemented. And then we will see enumerated type class designs, and then method design and method overloading will also be part of chapter 6, which is basically we have been designing methods, but how can we overload a certain method and then add additional functionalities depending on the method call. And we will have more GUI components and how these can be included and implemented in your applications. So software development activities will be the first part of this chapter. And when you look into the program development, so we have 4 basic activities that we need to perform in order to create our program. First, the main step is the requirement establishing, or finding out what are the requirements of your application that you're going to implement. So this is also considered to be the if you have reports in your project or in your program, this is the requirements stage where you have the requirements settled and created, and you know what you need to do for the application. So this is important because if you don't know the exact requirements of the application, you won't be able to perform the rest of the design in a good manner. So you have to have clear idea of what are the requirements that you're targeting in your application. Then once you have the requirements, the next step is to create a good design such that whenever you go and implement the code, you should be able to easily divide the whole application or whole program into pieces such that you can just take one piece and then implement the code, and it will perfectly work with the rest of the application or the project you have. So creating a design is also a crucial step. Implementing the code is it's kind of the most uninteresting portion of the application design normally, but for you it may seem to be the most important or interesting part. The rest you may seem to find it really boring and unnecessary, but believe me, in real life, in real applications, one of the most important parts is creating the design. Actually, how it is designed is the most most important, one of the most important parts of the overall design, because implementing the code is kind of the work that is going to be done based on this. So you have to come up with a good design. And obviously you have to test your implementation at the end to see if there are any flaws or any problems in your design. That's also important. And if you consider the engineers that are hired by Microsoft or any software development company, 1/3 of the engineers are hired for testing positions. So you have to test your software rigorously in order to say that, hey, I have a perfectly running application that is going to have no bugs or no problems. Obviously it's hard to say that, but at least you have a confidence up to a certain limit. These activities are not strictly linear, so you start establishing the requirement, create a design, and follow the steps, and then you're done at the end. This is basically reiterating, going over and over into the initial steps, because when you try to implement the code, you find out that you omit one of the requirements that must be listed in the requirements stage. So you go back and revise your requirements representation, and then change it, modify it accordingly. Or whenever you implement the code, you see that, hey, I have been using the same part of my code over and over, so let me reiterate and correct my design such that I utilize that code in those two pieces, and revisit your design is also going to be a possible option. So you go back and forth and iterate over these activities when you're developing a program, and this should probably be the case for your applications or for your projects as well. So you will have an initial requirement set up, but later on you will find out that, hey, this can be modified to this, and you'll change your requirements and add something else for your requirements, for example. Or you will find out something is really hard to implement, and you will change your idea to modify it somehow differently so that your requirements will be changing. So this is again the activities that are needed. When you look into the requirements, we see that the requirements specify the tasks that you have to accomplish at the end. However, it does not give the details of how it is implemented in reality. So it is basically indicating what you want to do at the end of the day. So that's going to explain what to do, not how to do it. So this is important about the requirements. You don't go into details of explaining any of it. So with your requirements specification report, you should have already done this. So you don't go into details, but you explain what you would like to achieve with certain part of your code, and then you will collect these to come up with the overall program description or requirement report. So you may want to expand your initial requirements. So you start with an initial requirement, but then later on you find out it's not sufficient, so you give details. You may start with a short list, and then you expand your list as you go with your implementation. So this is an important step, and as it is said here, it's really difficult at the beginning to come up with the complete requirements report. And you will find out some of the requirements later on, so you will come back and correct those issues. And it is important to pay attention to the requirements as you will design your overall project based on this requirement specification. So if this specification is wrong, if you didn't understand the requirements of the software, software purchaser, if you don't, for example, you're designing a software for a certain task that is going to be achieved by for a certain topic, if you don't listen to the person who is requesting this software package from you, if you don't understand his or her requirements really well, then you won't be able to achieve a good and final result as a program. So you would like to pay attention to the requirements as much as possible, and that's important because the rest of the program development will depend on that. So it's really important. And when you look into the design, it will indicate how a program will actually behave to the requirements and how it is going to achieve the tasks in the requirements. It is going to design such that you know how this solution is going to be broken down into smaller pieces. So you will say that, hey, I'm going to design my application such that it is going to have this component. For example, if you have a user system where there are users and admins, you will say that, hey, I will create a portion that is going to deal with the users, and then I will create a portion that is going to deal with the admins, and then I will have, for example, a GUI class library which I'm going to use for graphical representations, and then I will have a database that I'm going to connect all these into. So different components, how you decompose it is going to be dependent on the software design. So you would like to, have a good interaction between these pieces. And in object-oriented methodology, what we are actually paying attention to is how these components will interact with each other. So in terms of the classes, so we will separate our design such that we have multiple classes, such as, for example, in a system where you have university administration, you have the students class, you have the for example, faculty class, and then you have administrators class, you have the secretary class, and all those classes, and you have the interaction between those different pieces is important, and this is part of the design. So you will, next thing that you're going to do with your projects is designing your software. So you would like to divide your software such that it is manageable in smaller pieces, and then you can implement them one by one and just connect them to generate the overall application. So that's important. How you design is a crucial portion of it. This is actually one of the most important parts, because again, implementing and writing the code on the computer is not really an interesting task. It's just, you just achieve whatever is needed by the code, but designing is more crucial. You may make the application really slow with a bad design, and then you make it so fast with a good design. So it really evaluates, it really means what your application is actually doing in low details. So there are two types of design. You have high-level design and low-level design. In high-level design, you don't go into the low-level details. However, in low-level design, you have explaining the individual methods and how these are going to accomplish their results. So in each class, you have certain methods. For example, in low-level design, what you will identify is that what each of these methods will do in the implementation. So again, but you're not going into the details of coding at all in the design phase. Once your design is purely safe and really nice, you have a nice implementation in terms of your design, then you go into the actual coding part, which is called the implementation stage. So you translate the design into the source code. Once you know what classes you have already designed and then which methods they will be implementing, writing the code in it is going to be really easy to come up with. Again, this is not really interesting, and almost all important decisions are made during requirements and design stages. So up to this point, you should have already decided which component is going to interact with which other component in what fashion should have already been decided. So this is not really an interesting part of the, as it said, it's the least creative step in your application design. Although you may find it not true at the moment, once you start working on your project, you will see that if you go directly into the coding, you will face problems, and then you need to go back and correct your designs afterwards. So it's important to focus on the design more than coding. So once you have a good design, you will get the code easily. Testing, so as I said earlier, it is you attempt to check whether there are any issues or any problems. For example, the most important things that you want to test with your application is, for example, does it accept any wrong input from the user? For example, the user enters a value that you would like to check for a certain, for example, age input. If somebody enters a negative age, you should raise an exception. For example, the first thing that you may want to check is that whether does it accept correct input or not. So the data range is correct or not. And then other logical errors in your application, you should also check those. So debugging is the process of determining or finding out such errors. If you catch them, you try to correct them, obviously, and then fix them. So if you have a true application that runs without any flaw or any errors, that's what you would like to achieve, but it's always hard to come up with a perfect running application where you have no errors. as you have seen with with many Microsoft or other software vendor softwares, you see that there are lots of bugs here and there which you catch and you report to those software vendors. So with those $1 million companies with 100,000 employees, it's still not easy to come up with a fully working without error-free application. However, if you try to catch those errors, you can catch them mostly in the testing purposes part. So when we identify the classes and objects, so our goal is, as you know, in the object-oriented design, we would like to identify the classes and objects such that we have a good design in our software. So that's a critical part, as I said earlier. So you could use library resources that are already available, which is provided, for example, by Java, or you can create your own package from scratch for those things that do not exist, or you can rewrite them from scratch. And the one method that you can use to identify what kind of objects do I need, what kind of classes should I implement, is going back to the requirements. So once you go to your requirements report, for example, for your projects, you can see what are the things that you may need in your application. Let's see an example of this. So for example, this is a partial requirements document which lists what are the requirements that you're expecting from your program. So it says the user must be allowed to specify each product by its primary characteristics, including its name and product number. If the barcode doesn't match the product, then an error should be generated to the message window and entered into the error log. The summary report of all transactions must be structured as specified in section 7.a, whatever that section indicates. So as you can see, this is a small, part of a requirements specification document. When you go look into this document, what do you think might be the classes in this small requirement? What are the classes or objects that you may want to implement in this scanner? So, for example, what you may want to check is that actually the nouns are the things that you probably want to use as objects or classes, right? For example, the user. So you may want to have a user class which is going to implement the users. Or you may want to have, again, another noun which is product, which is going to be another class, for example, which you may want to implement. Not all of the nouns will actually convert to classes, but it actually gives you an idea of which one of these things might be the classes that you have. So here you see that in product it says the primary characteristics include name and product number. So you probably have a class for product which has a name and then a product number. So usually once you look into the once you look into the requirements document, you can at least have an idea which one of these are going to be your actual classes or objects. So not all the nouns will correspond to a class or object in the final solution, but again, it will give you an idea. So here you have the transactions, error log, you have a message window, summary report, error, barcode, product, and all this will give an idea what the objects you may want to have. So for your projects, you can go ahead and check your requirements specification and find out what could be the objects or classes you may have. Again, it's not giving the whole picture, but at least gives an idea. So as we said earlier, a class represents a group of objects with the same behavior. So once we create a class, we think that there are going to be multiple items that are going to be needed for this specific type. And for those things, we will use singular names for our classes, such as coin, student, and message. So this is the the way to represent or indicate these classes. And a class will represent the concept of one such identity, and we can instantiate as many objects as we like according to the requirements. So sometimes you may want to prefer coming up with the new class for example, in this example, they're giving the address object. So you may want to create an address class for addresses. For example, if you have a student class and an employer or faculty class, which in both cases you have an address field, right? So both of them may have an address that is designated to each faculty and each student. Then in that case, you may want to create a class that is going to indicate the address with its subfields. For example, in an address, you may have a street and then zip code, and then you may have a city and you have country and so on. So the address field may itself just be one string instead of creating a whole class for it, or you can again create a whole class for that. So the idea or the decision is up to you. Whichever is suitable for your design implementation, you will go with that. Either you will select one string that is representing the address, or you create a new class for representing the fields with the address. So again, if it is too complex, if it is making it too complex, you may want to skip and use one single instance. Otherwise, you may want to create a class for that. So it's up to the designer. Whichever is more suitable for implementing it should be chosen. However, you don't want to make it, you don't want to create classes for even individual small pieces. At the same time, you don't want to make classes so complicated, so you would like to separate or divide it into smaller pieces. So you have, let's say this is the whole picture you have. You would like to divide it into pieces, such as, for example, these smaller classes. But at the same time, you don't want to make it such small classes that, you have tiny little pieces which is represented by every class in a separate class, okay? So for example, again, an example is given here. It may be unnecessary to create separate classes for each type of appliance in a house. So you may want to create one general class which is saying appliance, and then give properties of these appliances by using this class, instead of having for example, fridge class and then oven class and all those classes separately. Instead, you may want to create an appliance class that generally describes all features, which could be, for example, the electricity consumption, the weight, the dimensions, and all the details about the appliance could be used or represented by an appliance class. So one of the important things while you are designing your objects or classes is that how are you going to assign the responsibilities to each class? Which class is going to perform what actions is also an important feature that you need to be aware. And in each activity you have with the program specification. So if you remember, in the requirement specification we had certain activities that are represented by verbs, right? So we had the verbs that represent, hey, you need to collect barcode, for example. So that collection is needed to be represented somehow. How can we represent those verbs or those things that are needed to be accomplished in a class? By methods. So if we use methods and implement them for such activities, we can implement them, and we generally use verbs to represent these method names. And in the early stages, you may not be able to identify all the methods that you need to have. However, you have a general idea of the main things that you will need, right? So you won't need the internal low-level implementation methods or inner methods that you may want to use at the beginning, but you will at least have a general idea of the main methods that are needed at the beginning. So this is about how to identify your classes and objects. Again, this is important because the rest of the design will depend on this. So you would like to have a good design in identifying your classes and objects. And then the next thing is, as we said earlier, is static variables and methods. If you recall, the static method is the one that can be invoked through its class name. So in this case, we're calling this square root method, which is an static method, by the name of the class, not an object, so it belongs to the whole class, right? So also you could have static variables that you could use. So if you want to declare a certain variable, that is going to be accessed by all the objects, you will declare it static. So if you want to, for example, keep a counter that is going to keep how many objects have been created so far in the class, you need to have a static variable to keep track of that, right? So the static modifier associates the method or the variable with the class rather than the objects or individual objects that you have. So these are called class methods or class variables as well. So let's consider the complications or the differences, what would happen if you have a static variable or not. In each object, you have a own data space that is reserved for the object, right? However, with the static variables, there is only one space allocated for the static variable with the creation of the first object. So whenever you create the first object of that class, then you create the area that is going to store the variable price. So with the first, with the first created object, you will have the area reserved for the static variable. So once objects instantiate afterwards, they will all share the same price variable with the originally created one, and all of them will use the same variable. So if you want to keep track of a certain value that is accessed by all the objects, you would like to define it as a static variable, right? So if you change the value of a static variable in one object, it is going to be updated for all. So they all refer to the same static object. I will show you an example shortly about that, so it will be more clear. And when you look into the helper class here, we had the static in cube. So if I want to call this method, how am I going to call it? So I will call helper.cube, and then the argument that I have. So I have value is equal to helper.cube, and then we have the argument 5 that is passed to it. And then when you look into the static class members, we see that the orders of the modifiers can be changed, but usually in convention we use the first visibility modifiers, then the rest. Public, static, void, main type of order is public starts first. And static methods cannot reference instance variables. Why cannot we reference the instance variables in the static methods? So in a static method, I'm not supposed to use any instance variables. Because they're not dependent on the instances or the objects, right? They are part of the class. So you should never use a variable that is not a static or a local variable. So you always need to use a static variable or a local variable in a static method. You cannot use instance variables. I will explain it more precisely in the coming slide. However, you can use, again, a static variable or a local variable in your implementation. So let's see the slogan counter example to make it more concrete. So when you look into this slogan.java file, this is the class, public class slogan, and then I have the instance variables, string, phrase, and then I have a counter that keeps track of the number of slogans I have so far. And note that this is a static variable, so this is important. I can only access this static variable if I have a static method that can only access this static variable. So when you look into the slogan constructor, as you can see, it takes an argument string, and then based on this string, the phrase, which is the instance variable, is assigned to the str that is passed as an argument, and then I have this counter incremented by 1. So this indicates how many slogans have been created so far. So my counter, again, it's a static counter, and every time one object is created, that is incremented by 1. So the toString method obviously returns the phrase, whatever that phrase that you created with the slogan is copied as a result of the toString method. And then this is a static method which is indicated by the static modifier here. Public static int get count and then return count. So I'm able to return this count because it is a static variable, right? Since it's static variable, I can use it in a static method. So this basically returns the number of slogans created so far. If you go into the slogan counter class, we have the main method. So I have a slogan object and I create a new slogan, object new slogan, remember the Alamo, and then I print that object. So it's going to call the toString method. And then I have the second object which is going to create don't worry, be happy, and then I will have live free or die, and all of them is going to be printed one after the other one. As you can see, these are all separate objects that are created for each slogans. However, when you print out the number of slogans created so far, what is it going to print? It's going to use the static variable, which is the counter, the count variable that we were keeping, and in this case 5 or 6 will be printed according to how many slogans we have. 1, 2, 3, 4 and 5 will be printed, right? So again, this is apart from any class object, it is the property of the class itself, so that's why you call it the static method, and it returns the number of objects created so far. So when you execute this, so it's going to create all these objects. Whenever it is created, whenever the constructor is called, counter will be incremented by 1, so that after this one, count will be equal to 1. After this one, the static variable count will be 2, 3, 4, and 5, and then slogans created will be printed as a result as 5. As shown here, this is the get count method, which is the static method we called. Any question? Again, if you want to keep track of things in the class level, you should use static variables. If you don't want to deal with the objects while you're doing some task, you want to do it with the static variables and static methods. Any question? Class relationships. So when you look into the class relationships, you can have various types of relationships, one to another. So main relationships we have are dependency. So A uses B, so A depends on B. And then you have aggregation. A has a B relationship, so you have a class that is used within one another. Classes A has a B relationship or aggregation. And then we have inheritance. A is a B. So if you have a let's say a person that's defined as B, and then you have a student. Student is a person, or a faculty is a person. So you could inherit the properties of B in A. So these are the three main types of relationships between the classes, and we will see the dependency and aggregation further in this chapter. So dependency exists if one class relies on another. So if it uses or implements and accesses some of the portions of this class, then we say that there's a dependency, and A uses B in that case. So we have seen this before, but you would like to want to design your application such that these relationships or dependencies are not too complex, and at the same time you don't want them to be too many at the same time. So you would like to decompose it such that you have a nice design where you have divisions between different classes, and at the same time you don't make it too complex as well. So as it is said, a good design strikes the right balance if you want to come up with a good design. So if you consider the dependencies, we have dependencies between objects of the same class. So an object's method may depend on the same class type of object, and this is also a type of a dependency which we cover. For example, a method of the class may accept an object of the same class as a parameter. So if you remember the concatenation in the string, we have a dependency between the string class and onto itself the same string class. So we use string 1, concatenation method uses another string as an argument. So string 1, the string class depends on itself, and it has a dependency onto itself. So this is kind of a dependency we have seen before. This drives the idea that the service is being requested from a particular object that you have in hand. The following, in this example, we have a rational tester.java and rational number.java, which is basically a rational number class. If you remember a rational number, right? So you have a numerator and then the denominator, right? How can I represent a rational number in that case? So if I want to represent the rational number class, rational number.java, what could be the instance variables in my rational number class? So I have numerator, right, which is going to be an integer, and then I will have another integer which is going to be the denominator. So I will have numerator divided by denominator as my result. And you may want to have some methods that are going to be handy to implement this class. So let's see those. Rational number.java, and then the other one was rational tester. So when you look into the rational number, this is the public class rational number, and then we have the instance variable, private int, numerator, and the denominator. So we have the two instance variables which is going to identify our number. And then we have a relational number constructor. As you can imagine, without the numbers you won't have the rational number at all. So you have two arguments, numerator and denominator. Now, according to the input, the constructor should behave correctly, right? If the denominator is 0, you should do something, either give some kind of an error message or something like that, or you can by default assign it to 1 as it is done here. So if the denominator is 0, you set it to be 1. And if the denominator is less than 0, what is done here is that, what does it do? If denominator is less than 0, so it's basically keeping the sign with the numerator rather than keeping it with the denominator. So if the denominator's sign is less than 0, meaning that if it is a negative number, I'll just update my numerator with multiplied by -1. So my numerator will be numerator multiplied by -1, so that I keep track of my, let's say if I have a number that is created as, if my method call is rational number, and then I have -5, -6, what this basically does is that in reality, in the object itself, while it's keeping it, it is updating. If the denominator is negative, it is reflecting onto the numerator, so that it is going to keep the number as 5 divided by 6 in the original case. If it is 5 minus 6, it is going to update the number such that always the sign is kept with the numerator, -5 divided by 6, since it's 6 same exact, right? So that's what it is done here. And you have a 0 denominator, it is updated as well. And then after these corrections are done, what you do is you keep track of your instance variables according to the new values. Numerator and denominator will be the updated values, whatever those are. And the reduce. So what does the reduce method may do? So if I have, let's say, 15 and then -5, right? It's going to make it -5 divided by 15. However, you would reduce this to the number that can be reduced at most. So you will make it -3 divided by 1 is the reduced version of it. How can you do this mathematically? You find the greatest common divisor, GCD, right? So that's what it is done actually with the reduce. So if you go below to the reduce method, I will explain each one by one. So the reduce method is called, I will update my numerator and denominator based on this. If numerator is not equal to 0, you will find the common divisor, greatest common divisor. So it will call the GCD of the denominator and the numerator. Remember that numerator could have a negative value, but denominator is always positive since I updated that. So it's going to take the absolute value of both first number and use the second number and generate the common value. If they have a common, greatest common divisor, greater than 1, it is going to divide both of them and update those. Right? Any question? So I find the GCD. Let's say in this case, the GCD is going to be 5 for these two numbers. So I will divide 15 minus 15 by the GCD, and then I will divide 5 with the GCD as well, so that I get minus 3 for the first numerator and then 1 for the denominator. So that's what it is doing. However, most, maybe you are familiar or not, I don't know, but the GCD is the, algorithm that finds the greatest common divisor is more interesting here. This is, obvious math calculation, you just divide. However, in GCD, how do you find the GCD of two integers? So you perform the Euclid's algorithm, right? By subtracting the minimum number from the larger one and continuing over and over to find the GCD of those two numbers. So that's what this GCD is doing. So it takes two integer values and then finds the GCD of those two numbers by subtracting the smaller number from the bigger one and doing this iteratively over and over until you get a value that is equal to one another. If one of them is 0, it's going to exit the loop and you will return the result or the GCD of the whole thing at the end. For example, if I have 21 and 12, what you do is you subtract 12 from 21 and then get a 9, and then subtract 9 from 12, get a 3, and then from 3 you subtract 9, here 6, and then you subtract again 3, you get 3, and then you subtract 3 from this and you get a 0. So at the end, until one of them is non-zero, which is 3, is going to be the GCD of those two numbers, and you'll just divide both of these 21 and 12 with this GCD. So that's basically what is happening here. And when you look into this, it is calling the GCD of those two values. So I call the GCD with the numerator and then the denominator and update those values. So going back to the rational number initially, so I get the inputs and I reduce the value according to this methods, and I get the result as a result of this method call. Once I have the constructor, you have other class methods, which is get numerator, so it just returns the numerator, get method, which is easy to write. And then you have the denominator, which returns the denominator. And then rational number reciprocal. What's reciprocal? You just take 1 over the value of the rational number, which is basically, you create a new number with denominator as the new numerator and then numerator as the denominator. So you just reverse the positions of those numbers and you get the 1 over whatever the original value is. So you have a rational number add. How can you implement this? So you have the common denominator. So you get the common denominator of those two values, right? So I have let's say I have 3 over 5 and then 2 over 3. What I do is I get the common denominator by multiplying those two, right? So I multiply denominator with the multiplied object, which is OP2, get denominator and multiply those two. And then I get the numerator 1 with updated, multiplying it with 3. I multiply this with 3 and then multiply this with 5, right? So that I get the numerator 1 and then numerator 2 updated. Then what do? I sum those new numerator results. So I sum the new value, which is going to be 9. This one will be 10. I so add those things up. 19, which is going to be the new sum. And I return this result as a sum divided by common denominator. 19 divided by, here in this case, 15. So it is going to create a new rational number and then return it. Since this is, yes, that's a good question, but if you recall, this is going to call the constructor with those two values, and then the constructor, in any case, it is going to call the reduce in itself. Remember, in the constructor, at the end, we have the reduce method call. So it's going to reduce it in any ways. So if you recall here, it's going to call the constructor so that it will do the reduce at the end. Any question? And subtract is similarly, you just subtract the, one from another, and that's easy to implement. Same thing, so you have the difference instead of the sum, and do that. And then multiply, how can you multiply? You just multiply the numerators and then the denominators, and you will have the new rational number returned as a result. Recall that this returns a rational number as a result, right? So the method returns a rational number at the end. That's why I had the new rational number called here. The constructor is called there. And if you have a rational number divide, what do? You take the reciprocal of the, the value, the rational number that you're going to divide, and then multiply it with that. It's basically what division is one multiplying 1 divided by the original number. Any question? And then equals. How can I do an equals check? Basically, since both of them must be reduced at the moment, then I can directly check the numerators and denominators to see whether they are equal. It will return a Boolean if the current, rational number is equal to the argument passed rational number. If their numerators match, and at the same time their denominators match. If this is true and this is true, the whole thing will return true as a result. Obviously, you could have written this using if statements, but this is more elegant to write. If you're going to write these kind of things, you should try to write them this manner. It's a lot nicer. And we have the toString method, which is basically going to, have a slash between numerator and denominator unless the denominator is equal to 1. Otherwise, it will, just print the numerator. So if it is 1, it will print numerator. Otherwise, it will print numerator divided by the denominator. So again, we have seen the reduce and the GCD. So if you want to see the rational tester, as you can see, it creates a rational number that is 6 divided by 8, and then another rational number 1 over 3. And it performs multiple things one after the other one. So it prints the first rational number, R1, and then the second rational number, R2, and it checks whether they are equal, else it prints they are not equal, and then it takes R3 as the R1's reciprocal, so 1 over the R1 value, and prints that result, and adds R1 to R2, and then subtracts R2 from R1, and so on. At the end, it prints all these results. So let's compile and execute this. And then that will be the end of it. So as you can see, the first rational number 3 over 4, the second one 1 over 3, R1 and R2 are not equal, and then the reciprocal of R1 is 4 over 3, and then you have R1 plus R2, R1 minus R2, R1 times R2, and then R1 divided by R2. So this is an example of a question that you may see in the exam as well, to design a class that is going to, for example, perform the tasks for imaginary numbers, for example, or any type of different class that you could create could be asked in the exam as shown here. So you may ask to write the methods that are needed for this class. Okay, let's continue after the break.